everyone. Today we are going to see our remaining portion of the noble gas chemistry. But if you haven't seen part first of this chapter, so watch it first and then continue with this. I left the link in the description box. Please check it. So let's start. We see three different terms. Number one is Genome difluoride. Second one is Genome Tetrafluoride, and third one is Genome Hexafluoride. Out of these three terms, one can be asked in exam, so it is very important topic, so do not skip it. I write here FIMP because it's very important for your examination. So first of all, we see Genome difluoride. Genome difluoride is a colorless, odorless, crystalline solid and the melting point of Genome difluoride is 140 degrees Celsius. It is dissolved in HF, means hydrogen fluoride. Then we see the preparation of Genome difluoride. Preparation. Genome difluoride is prepared by heating a mixture of xenon and fluorine at 400 degrees Celsius in sealed nickel tube. And we use xenon and fluoride at 1:2 ratio. Then we use Genome difluoride. This is the first method of preparation. Then we see the second method of preparation. Genome difluoride is also prepared by heating a mixture of xenon and fluorine in the presence of mercury vapors in sealed nickel tube. Sealed nickel tube. Then also we use Genome difluoride. This is two simple method of preparation. Then next one is structure and the bonding of Genome difluoride. Next one, structure and bonding of Genome difluoride. The atomic number of xenon is 54. The general outermost electronic configuration of xenon is 5s2 5p6. Therefore, the electronic configuration of xenon in ground state is 5s2 5p6 1 2 3 4 5 6, and it's having vacant d orbit. In excited state, this electron is shift in d orbit, and therefore the electronic configuration of xenon in excited state is 5s2 5p5 1 2 3, 4, 5 and 5D1. When two atoms of chlorine combines with xenon, then we use xenon difluoride. Therefore, the electronic configuration of xenon in xenon difluoride is 5s2, 5p6, 1, 2, 3, 4, 5, 6 and 5d, 1 electron of xenon and 1 electron of fluorine. In the formation of xenon difluoride, sp3d types of hybridization involves. Geometry. When we see the geometry of xenon difluoride, one atom of xenon and two atoms of fluorine that lie on a straight line, while three equatorial positions occupied by lone pair. Therefore, the possible geometry of xenon difluoride is linear. We can write it like this. Then we see the properties of xenon difluoride. Generally, xenon difluoride have a different properties, but in which some are listed here. First property of xenon difluoride is it is colorless, odorless, crystalline solid. Its melting point is 140 degrees Celsius. It is dissolved in HF. Next property is action of hydrogen. When xenon difluoride reacts with hydrogen, then we use hydrogen fluoride and xenon. Then action of water. When xenon difluoride reacts with water, then it evolves oxygen gas. Then action of iodine. When xenon difluoride reacts with iodine in the presence of B.F.3, then we use oxidized iodine, means iodine fluoride and xenon. And last one is the action of sulfur trioxide. When xenon difluoride reacts with sulfur trioxide, then we use xenon, and this is the byproduct of this reaction, that is S2O6F6. These are the different properties of xenon difluoride. So take a screenshot first, then we will see the next point. Next point, xenon tetrafluoride. First of all, we see the preparation of xenon tetrafluoride. Preparation. There are two different methods of preparation, in which first is xenon tetrafluoride is prepared by heating a mixture of xenon and fluorine at 400 degrees Celsius in a sealed nickel tube at 5 to 6 atmospheric pressure. Then we use Xenon tetrafluoride. Then second method of Xenon tetrafluoride is by passing an electrical discharge through a mixture of xenon and fluorine in a ratio of 1:2. Xenon and fluorine in ratio of 1:2 at -80 degrees Celsius. Then we use Xenon tetrafluoride. These are two different methods of preparation. Then we see the structure and the bonding of Xenon tetrafluoride. Structure and bonding. We know that the atomic number of xenon is 54 and the outermost configuration of xenon is 5s2 5p6. Therefore, the general outermost electronic configuration of xenon in a ground state is 5s2 and 5p6. 1, 2, 3, 4, 5, 6, and it also having vacant d orbit. By passing an electrical discharge in a ground state of xenon, then excitation of electron takes place from ground state to higher energy level. Then these two electrons are shifted from p orbit to d orbit. So therefore, the electronic configuration of xenon in excited state is 5s2 5p4 1 2 3 4 and 5d2 1 2. When four different fluorine atoms combines with xenon, then we use xenon tetrafluoride. So therefore, the electronic configuration of xenon in xenon tetrafluoride is 5s2 5p 4 electrons of xenon and 2 electrons of fluorine atom, and in d orbit 2 electrons of xenon and 2 electrons of fluorine combines with each other and form a new hybrid orbitals. In the formation of xenon tetrafluoride, sp3d2 types of hybridization involves. The possible geometry of xenon tetrafluoride is octahedral, but due to the presence of two lone pair of electron, it shows square planar. In a xenon tetrafluoride, xenon occupies the central position and 4 fluorine atoms are coplanar, while 2 equatorial position occupied by 2 lone pair. The geometry of xenon tetrafluoride is square planar. Then we see the properties of Genome Tetrafluoride. Properties. First property of Genome Tetrafluoride is it is colorless crystalline solid. Its melting point is 170.1 degrees Celsius and it is dissolved in HF. Then action of H2. When xenon tetrafluoride is reacts with hydrogen, then we use hydrogen fluoride and xenon. Then action of water. When xenon tetrafluoride is reacts with water, it undergoes disproportional reaction. Disproportional reaction means one type of redox reaction and it gives highly explosive xenon trioxide. Then action of BCl3. When xenon tetrafluoride is reacts with BCl3, then we use boron trifluoride means BF3. Then action of B.Sc.F.Y. When xenon tetrafluoride is reacts with B.F.Y, then it gives the additional compound called adduct. And after dissociation of it, we give xenon trifluoride plus antimony hexafluoride minus. So these are the different properties of xenon tetrafluoride. Then we see the last point, that is xenon hexafluoride. Then last point is xenon hexafluoride. First of all, we see the preparation of xenon hexafluoride. First method, xenon hexafluoride is prepared by heating a mixture of xenon and fluorine in 1:20 ratio at 200 to 250 degree Celsius in sealed nickel tube at 50 atmospheric pressure. Then we use xenon hexafluoride. Then xenon hexafluoride is also prepared by the interaction of xenon tetrafluoride and F2 under pressure. It also gives xenon hexafluoride. These are the two different methods of preparation. Then we see the next point, structure and bonding of xenon hexafluoride. Structure and bonding. We know that the atomic number of xenon is 54 and the general outermost electronic configuration of xenon is 5s2 5p6. So therefore the electronic configuration of xenon in a ground state is 5s2 5p6 1 2 3 4 5 6 and it's having vacant d orbit. When excitation of electron takes place in a ground state to higher energy level, then this 3 electron is shift in next higher energy level. Therefore the electronic configuration of xenon in excited state is 5s2, 5p3 and 5d3. When 6 fluorine atom combines with xenon, then we use Genome Hexafluoride. And therefore, the electronic configuration of xenon in Genome Hexafluoride is 5s2, 3 electron of xenon and 3 electron of fluorine in p orbit, and in d orbit 3 electrons of xenon and also 3 electrons of fluorine. When we see the hybridization of Genome Hexafluoride, we see that sp3d3 types of hybridization, because it involves 1 s orbit, 3 p orbit and 3 d orbit. So that's why hybridization is sp3d3 types. In the formation of Genome Hexafluoride, sp3d3 types of hybridization involves, so therefore the possible geometry should be pentagonal bipyramidal, but due to the presence of one lone pair of electron, it shows us the disordered octahedral geometry. In Genome Hexafluoride, xenon occupies central position and all 6 positions are occupied by 6 fluorine atoms, and one lone pair are present at the central of as a type of triangular face. I draw here like this, and therefore the possible geometry of Genome Hexafluoride is disordered octahedral. Then we see the properties of Genome Hexafluoride. Properties. There are different properties of Genome Hexafluoride, but in which some are listed here. So first property of Genome Hexafluoride is it is colorless crystalline solid. Its melting point is 49.5 degrees Celsius and it dissolves in HF. Then action of H2. When Genome Hexafluoride is reacts with hydrogen, then it gives hydrogen fluoride and xenon. Then action of H2 means action of water. When Genome Hexafluoride is reacts with water, it slowly undergoes the hydrolysis reaction and it gives highly explosive xenon trioxide. Then action of B.Sc.F.Y. When Genome Hexafluoride is reacts with antimony pentafluoride, then it gives the additional compound called the adduct. After dissociation of this compound, we use xenon pentafluoride plus and antimony hexafluoride minus. Then action of silica. When xenon hexafluoride is reacts with silica, then finally it gives the highly explosive xenon trioxide and which cannot be stored in glass or quartz vessel. So these are the different properties of xenon hexafluoride. We can remind all these fluorides of xenon by using this chart. So now we can stop here.